The, the Ganges-Brahmaputra Delta formation, structure, and environmental dynamics. Introduction. The Ganges-Brahmaputra Delta is one of the largest and most dynamic delta systems on Earth. Formed by the combined sedimentary output of the Ganges and Brahmaputra rivers, the delta spans a vast region across Bangladesh and eastern India before entering the Bay of Bengal. The immense deltatic complex has developed through thousands of years of sediment deposition, tectonic activity, climate processes, and fluvial dynamics. Scientific studies describe the delta as a compound system consisting of both subaerial and subaqueous components that extend across coastal plains and the continental shelf. According to geological research summarized in the document, the two rivers deliver roughly 1 trillion kilograms of sediment annually, making the delta one of the most sediment-rich depositional environments on the planet. The delta covers approximately 110,000 square kilometers of land area, and when the offshore subaqueous delta is included, the total area expands to nearly 140,000 square kilometers, roughly comparable to the size of Great Britain. Over time, this enormous system has been shaped by tectonic subsidence, river migration, monsoonal hydrology, and coastal processes. The result is a complex geological environment where river channels, floodplains, tidal floods, and marine sediments interact continuously. The delta also supports one of the highest population densities in the world, making its environmental stability crucial for millions of people. Geological setting of the delta. Tectonic framework of the Bengal Basin. Unlike many major rivers that flow through passive continental margins, the Ganges and Brahmaputra originate in the actively rising Himalayan mountain belt. These rivers transport massive quantities of sediments derived from Himalayan erosion and deposit them into the Bay of Bengal basin, a tectonically active region located between the Indian Shield and the Indo-Burman Fold Belt. The Bengal basin has been subsiding since at least the Eocene period, due to the ongoing collision between the Indian Plate and the Burmese Plate. This long-term subsidence has created a deep sedimentary basin capable of accommodating extremely thick sequences of deltaic sediments. Geological studies indicate that the total thickness of sediments in parts of the basin may reach up to 20 kilometers, illustrating the enormous scale of deposition that has occurred over millions of years. Despite the tectonic activity, the surface of the basin is relatively flat. The upper delta plains slopes gently towards Bay of Bengal, while elevations generally ranging between 10 and 15 meters above sea level inland and decreases towards the coast. The basin is bounded by several structural features, including the Shillong Massif and the Indian Shield, as well as the Tripura Fault Belt, collectively which collectively influence the distribution of sediments and river channels across the region. The river systems feeding the delta. Origins of the Ganges River. The Ganges originates from the Gangotri Glacier in the Himalayas. From its mountainous source, the river flows southward through steep valleys before emerging onto the Indo-Gangetic plain. Once on the plains, the river turns eastward and receives numerous tributaries that drain vast areas of northern India. These tributaries contain both water and sediment, significantly increasing the river's discharge before it enters the Bengal basin. The geology of the Ganges drainage basin includes a mixture of Precambrian metamorphic rocks, sedimentary formations, and volcanic depositions. As a result, sediments transported by the Ganges contain a distinctive mineralogical composition reflecting these varied source rocks. Origins of the Brahmaputra River. The Brahmaputra follows a dramatically different route. It originates on the northern side of the Himalayas in the Tibetan region, where it flows eastward as the Yarlung Tsangpo River across the Tibetan Plateau. After traveling hundreds of kilometers, the river curves sharply around the eastern Himalayas and descends southward into India and Bangladesh. This river drains a drainage basin dominated by Mesozoic sandstones, shellies, and limestones, along with older crystalline rocks. The distinct geological composition of the Brahmaputra basin produces sediments with different mineralogical signatures compared to those of the Ganges. Combined drainage and sediment load. Together, the two rivers drain an enormous basin of approximately 2 million square kilometers. The Ganges basin covers about 1.1 million square kilometers, while the Brahmaputra basin covers roughly 935,000 square kilometers. During the monsoon season, this river carries extraordinary volumes of water and sediments into the delta. Seasonal rainfall and glacial melt combine to produce peak discharges that transport massive sediment loads downstream. Estimates suggest that the combined system delivers around 10 to the power of 12 kilograms of sediments per year, making it one of the most powerful sediment transporting river systems in the entire world. Climatic and oceanographic influences. Role of the monsoons. The hydrology of the Ganges-Brahmaputra Delta is strongly influenced by the South Asian monsoon system. Most of the river discharge occurs during the summer monsoon months, typically between May and November. During this period, rainfall across the Himalayan catchment areas increases dramatically, causing river levels to rise and floodplains to expand. Studies indicate that approximately 80 to 90% of the Ganges' annual water discharge occurs during the southwest monsoon season. For the Brahmaputra, this figure can reach till 95%, highlighting the extreme seasonality of the river system. During the dry season, discharge decreases sharply, often dropping to one-tenth of the peak monsoon levels. This seasonal variation plays a crucial role in shaping sediment deposition patterns and controlling the formation of channels and flood basins. Ocean circulation in the Bay of Bengal. The Bay of Bengal exhibits complex ocean circulation patterns driven by monsoon winds and freshwater input from rivers. During the summer monsoon, surface circulation forms a large anticlockwise gyre, where in winter the circulation reverses direction. Freshwater discharge from the Ganges and Brahmaputra creates a large, low salinity surface layer that spreads across northern Bay of Bengal. This layer can extend 50 to 100 meters deep, significantly altering ocean stratification and nutrient circulation. These oceanographic processes influence sediment transports, coastal currents, and the deposition of sediments across the continental shelf. Morphology of the delta. Upper delta plain. The upper delta plain forms the inland portion of the delta system and extends approximately 200 kilometers landward from the coast. This region dominated by fluvial processes such as river migration, channel avulsion, and floodplain deposition. Important Several important geological features influence the structure of the upper delta, including the barren tract and the Madhupur terrace. These elevated surfaces consist of older alluvial deposits that rise above the surrounding floodplains and are not inundated during seasonal flooding. Their presence strongly affects the pathways of river channels and the distribution of sediments across delta. The upper delta plain also contains numerous flood basins, which accumulate fine-grained sediments during seasonal floods. One of the largest is the Sylhet Basin, which covers approximately 10,000 square kilometers and has experienced long-term tectonic subsidence. Lower Delta Plain. The lower delta plain lies closer to the coast and is characterized by the tidal influence and saline water intrusion. Elevations in this region are extremely low, generally less than 3 meters above sea level. Historically, much of the area was covered by mangrove forests, particularly in the Sundarbans, which remains the largest mangrove ecosystem in the world. Today, large portions of the lower delta plain have been converted to agricultural land, although tidal channels and mangrove forests still play an important role in the coastal ecology. Sediments in this region consist primarily of silts or clays, which relatively are of small amounts. Sediments rise at the lower delta plain can reach up to 1.1 centimeters per year, reflecting the continued deposition of fine sediments transported by tidal currents and coastal storms. Subsequent delta and continental shelf. Offshore sediment accumulation. Beyond the coastline lies the subsequent portion of the Ganges-Brahmaputra Delta. This underwater extension forms a large clinoform deposit across the continental shelf. The structure includes three major components: topset beds near the coast, foreset beds near the continental slope, bottomset beds farther offshore. The foreset region experiences the highest sediment accumulation rates, sometimes reaching 5 to 9 centimeters per year. These sediments gradually build outward, causing the delta to prograde seaward across the shelf. Swatch of No Ground Canyon. One of the most remarkable features of the offshore delta is the Swatch of No Ground, a large submarine canyon near the western margin of the delta. This canyon acts as a major conduit, transporting sediment from the shelf to the deep ocean. Research suggests that roughly one-third of the sediment carried by the Ganges-Brahmaputra system is funneled through this canyon, ultimately contributing to the formation of Bengal Fan, the largest submarine fan in the world. Environmental hazards and cyclonic activity. The Bay of Bengal is one of the most cyclone-prone regions on Earth. Tropically, cyclones frequently form over the warm waters of the Bay of Bengal and move northward towards the deltaic coast. These storms generate powerful waves and surges that can inundate large portions of the low-lying delta. Historical records indicate that more than 130 cyclones struck the Bangladeshi coastline between 1877 and 2001, with dozens reaching destructive intensity. The most catastrophic event occurred in November 1970 when a powerful cyclone produced storm surge up to 10 meters high, causing approximately 500,000 fatalities. Cyclones can also play a role in sediment redistribution by mobilizing shelf sediments and depositing them across coastal plains and islands. Human interaction and societal importance. The Ganges-Brahmaputra Delta supports one of the densest human populations in the world. Bangladesh alone contains more than 140 million inhabitants, many of whom live within the deltaic region. Agriculture, fisheries, and river transportation all depend on the dynamic river system. However, the same process that sustains the delta also creates several risks: flooding, riverbank erosion, and cyclonic storms threaten communities throughout the region. In addition, human interventions such as dams, embankments, and river control structures have begun to alter natural sediment flows. Climate change and global sea level rise further causes uncertainty because much of the delta lies only a few meters above the sea level. Even a modest increase in sea level could lead to an increased flooding, salinity intrusion, and a loss of agricultural lands. Conclusion: the Ganges-Brahmaputra Delta represents one of the most complex and dynamic sedimentary systems on Earth, formed through the combined influence on tectonics, monsoonal hydrology, and immense sediment transportation. From the Himalayas, the delta has evolved over thousands of years into a vast landscape of rivers, floodplains, mangrove forests, and offshore deposits. Its geological structure reflects a delicate balance between sediment supply, tectonic subsidence, and sea level change. Seasonal monsoon floods and coastal currents and cyclone storms continually reshape the delta, while offshore processes transport large volumes of sediments to the deep ocean. Beyond its geological importance, the delta is also a critical human environment. Millions of people depend on its fertile soils and abundant water resource. Yet the same natural processes that create the delta continue to pose challenges for human habitation. Understanding the geological and environmental dynamics of the Ganges-Brahmaputra Delta is therefore essential not only for scientific reasons but for sustainable development and disaster management in one of the world's most densely populated regions.